Hey guys, welcome to the channel, and in this video I will be explaining one question on dynamic programming, that is to found the number of ways to make a change. Now what this problem is, first I will explain you with the help of the example. Let's say suppose here we have given the denomination of 1 rupee coin, 5 rupee coin, 10 rupee coin and 25 rupee coin. Okay, and these are the coins given to us in infinite amount of quantity. So what's our purpose is, we have given one denomination like 10 rupees we have to make, and we have to find the number of ways in which we can use these coins any number of time and make a change of 10 rupees. So if I give one example, let's say if we take 1 rupee coin 10 times, that means effectively we are taking 10 1 rupee coins, then we are getting a change of 10 rupees. Okay, so this is one way we can take. Second way we can do is, we can take 5 1 rupee coin and 1 5 rupee coin. So this second number represents a quantity and this represents the denomination, so this also sum up to 10 rupees. There is one more way we can do it. We can take 2 5 rupee coins and get 10 rupees, and there is one more way, that we can take one 10 rupee coin and get a 10 rupees denomination. Now let's see how to solve this problem with the help of the dynamic programming. If I will not solve with the help of the dynamic programming, then this problem will go in more time complexity. It will go in exponential time complexity. So for simplifying that time complexity, we are using dynamic programming in this approach. So why we are DP in this approach is because the solution or the answer which we have generated previously, we can use that solution to find the total number of changes which we can get, or the number of ways which we can get. Okay, so here what we have to make a change of 10 rupees coin. So here we are taking one array of size equal to the number of donation which we have given to us to make a change of +1. So our size of the array will be of 11. Why I took this 11, I will show you in a minute. Just wait a second. Okay, so what this index represent, that we are given a denomination of 10 and we have to find the number of ways to make a change of this denomination. This represent we have given a denomination of 9, and what are the number of ways to make a denomination of 9, and so on. So this index represent that only, and we are iterating j over this. So why we are iterating why we are taking this all the values like 0 1 2 3 4 5 6 and so on, because when we are calculating number of ways to make a change for 1 rupees denomination, then we require 0 rupees denomination also. So these values directly or indirectly dependent on the previous values which we have computed earlier. So we have created this memo which will help us to solve this problem using DP approach, and we use the same values which computed earlier. So now let's filling out the base conditions. In the 0th index we are filling out 1. Why this one? Because if we want to make a change of 0 rupees, the number of ways in which we can do is 1, because we don't choose any of the coins, so that's our choice. So in this case, the number of ways to make a change of 0 rupees denomination is 1, and rest we all fill with 0, because initially we don't know what are the number of ways we are provided with. So these all values are initialized with 0. After that, we are iterating our I variable on this coins which we are given to us, and we are iterating our j from first location to the last location for each iteration of I. Okay, now for updating this value, the condition which we need to check is, if the corresponding denomination which we are at is less than equal to j, then only we need to update this table. Because if this condition is false, let's say array of I is greater than j, here in this case 25 is greater than this j 10, so there is no way we can make a change of 10 rupees using this 25 rupees denomination, so this is useless to us. So for removing that conditions or checkings, we are doing this, like if the denomination which we are provided with is less than equal to j, which we need to get, then only update this table. Okay, so currently our j is at this first location and our I is at this 1 rupees denomination. Now we check this. If array of I, that is 1, is less than equal to 1, yes, it is true. That means we need to update this value. So this value is updated with this value is updated with, suppose we have this value as memo of j, so this memo of j is updated with whatever is present in memo of j plus whatever is present at memo of j minus array of I. Because see, whatever is the value which is already present there, we have to add the values after taking that denomination also. So if we take out this denomination of 1 rupees from the 1 rupees which we are provided with, we are left with 0 rupees denomination, and the number of ways to make a change of 0 rupees is 1. So this value is updated with 1. Likewise, increment the j. Here we will check that 2 here we will check that 1 is less than equal to 2. Yes, this condition again 2. So whatever is present at memo of j, we have to add that value with memo of j minus array of I, that is 2 minus 1, that is memo of 1. So this memo of 1 contains the value 1, so this value is again updated with 1, and so on. I will, for 1 rupees denomination, this all values will be updated with 1. Because with the coin of 1 rupees only which we have given to us, the number of ways in which we can make a change of 0, 1, 2, 3 and so on up to 10 rupees coins is 1 only. After that, we need to increment our I location to the I index to the next location. Okay, so when we update our ith location, I will shift it to this 5th index or 5th coin denomination, and our j again start with the jth index, which is 1. So this condition is false until we reach this 5, because 0, 1, 1, 2, 3, 4 is anyways less than this 5, so we will not updating these values for this 5. The j is when moves to this location 5, we check that this 5 is greater than or equal to this 5. That means array of I, which is this 5, is less than equal to j, which we are at. So we update the value which is present at this location, that is 1, with whatever is value present there already, plus memo of taking this 5, that is j, 5 rupees denomination which we are provided with, that is 5, and subtracting with the coin which we are at. So it is memo of 0. So memo of 0, as we can see, the number of ways to make a change of 0 rupees is 1 only. So 1 plus 1 is 2. So this value is updated with 2. So let me erase this down, which I have calculated earlier. Okay, so if I change this value is updated with 2 now. Now see how it 2 came. So for making a change of 5 rupees, we have two choices. Either we can take 5 1 rupees coin, or we can take 1 5 rupee coin. So these are the coins. Okay, therefore this value is updated with 2. After that, increment the j. Now j at is this location. We need to check that 5 is less than equal to this 6. Yes, it is true. So update this value is whatever present here plus whatever present here, that is 1, plus memo of j minus 6 minus 5, that is 1. So memo of 1 is 1 only. So this value is also updated with 2. Same like this value is also updated with 2. This also updated with 2. And if we check here, this value is also updated to. Now let's see what happens when j reaches here. When j is here, 5 is still less than equal to 10. So this condition is again 2. So we need to update this value. So for updating this value, what we have the value present here already, plus the value present at the location 10 minus 5, that is 5. So value present at location 5 is 2. So number of ways to make a change of 10 rupees using denomination 1 and 5 is 3. So why this 3 came? we can take one 10 rupee 10 1 rupee coins, 2 5 rupee coins, and we can take 5 1 rupee coin and 1 5 rupee coin. So these are the three ways in which we can get a denomination of 10 using these two coins which we are provided with. And likewise, after that, what we have, we need to update or increment our j to the next location. So when we increment j, it will reach outside of the loop. Therefore, j is again starting from here and I is incremented. So I is at 10. So from 1 to 9, there is no change because this condition is false. So j will move to this location. When j is at this location, this value is updated with whatever is present here already plus memo of 10 minus 10, which is 0. So 3 plus, well, what is the value to me present at memo of 0, which is 1. So this value is updated with 4. So number of ways to make a change of 10 rupees coin using the denomination 1, 5 and 10 as 3. Sorry, 3 not 4. 4. It's 4. After that, I is incremented to the next location and this value is 25, which is greater than all of this. So j is iterating over all this and come out of this loop without changing any value. So we got our answer. We got our answer as 4. The number of ways to make a change is 4. So this is that only which I have showed you. So now the time complexity for this case is we are iterating over this array number of times which we have given with this denomination. So if we have given the coins or the different coins, let's say n different coins, and we have to make a change of m rupees, then the overall time complexity in this case is order of mn, and the space complexity is order of m, because we are taking this extra array which is equal to the size of the denomination which we need to make a change of. Okay, so now let's see how to code this. Here we have given the denomination, like we have a denomination of 1 rupee coin, 5 rupee coins, 10 rupee coin and 25 rupees coin. So these are provided with us in infinite amount of times or in quantity, and we have to make a change of, let's say, not here 2, we have to make a change of, let's say, 10 rupees, which I have showed you in the example also. So we have to make a change of 10 rupees here with the help of these coins, and we have to find the number of ways in which we can make this change. Okay, so now let's see how to code this. Here what we have created one function ways to make a change, in which we have taken the argument, that is the array which represents the number of coins provided with us. So this is 1, 5, 10 and 25. So these are the coins provided to us in infinite amount of time. This represent the number of coins, that is 4, and this represent what is the denomination which we need to make a change. So if we see this, the answer is we can take 10 1 rupees coins, we can take 2 5 rupees coin, we can take 5 1 rupees coins and 1 5 rupee coin, and we can also take 1 10 rupee coins. So there is number of ways is 4. So we have created this memo which is equal to the size of rupees plus 1. The rupees is provided with us is 10, which we need to make a change of, plus 1, and we are setting all this value with 0 because initially we don't know the number of ways to make a change using these values, and we are initializing memo of 0 with 1 because to make a change of 0 rupees we require nothing, we require no coin. So that's one way also, because to make a change of 0 we require 0 coins, so that's also one way. So therefore initially we are initializing memo of 0 with 1. And these are the two loops which I have explained you with the help of the example also. That is, I start from this index of our coin till this index, and j start from 1 to the denomination which we need to make for each iteration of I. And we need to check this simple condition. That means the denomination which is provided to us, let's say 1, 5, 10 and 25, it should be less than or equal to the current j. Okay, so current j index represent that we need to make a change of that rupee coin. So if we are at, let's say our j is provided with us like 0 to 10, and if we are currently at this location 4, then this 4 index represent that we need to make a change of rupees 4 with the help of these given denominations. Okay, so if this condition is satisfied, then we need to update the memo of j, that means that particular denomination index value with whatever is present there. I have written plus equal to here, that means whatever is value present here at this location earlier, this value is added to that. So this value represent that if we take this coin, let's say 1 here, and we are at the location of j as 4, then we have taken this one value, and after removing this one value from the 4, we are left with 3. We are left with 3 rupees which we need to make a change of. So we check that whatever is present at this memo of 3, we add up to the values at memo of j. So these added up and gives us the number of ways to make a change of that particular index. After that, we need to find that what is the number of ways to make a change of 10 rupees coin which is present at our this last index or last location of our memo. So we are simply returning that. So hope you got this problem. This is a simple problem to find the number of ways to make a change. Let's see what's the time and space complexity in this case. I have explained you earlier also, but let's see here also. So this is O of n, and let's say we have to make a change of Rs rupees. So in this case, let's suppose if I take Rs is equal to m, the complexity of this is O of n. So overall time complexity in this case is O of mn, and we are taking one extra space of size equal to Rs, which is equal to m. So space complexity is O of n. Now let's see using the running of this code. If we compile this code, this is compiled successfully, and when we run this code, it gives us the output of 4, which I have showed you in the example also. So hope you got this problem. If you find difficulty in understanding this question, please feel free to comment and I will help you.